Hi, everyone. Welcome to another Avalanche Developer Community Call. My name is Michelle Tien, and I lead the interoperability efforts on the product side at Avalabs, and I'll be your moderator today. So we are discussing ACP-108 EVM event importing, and this Avalanche community proposal suggests a standard smart contract interface for importing EVM events within Avalanche blockchains. And using Avalanche Warp Messaging, it enhances cross-chain messaging by enabling importing information from one chain into any other chain without interacting with that source chain directly. So for today's agenda, we're going to start with Michael Kaplan, who is the ACP author, and he's going to talk through the ACP as a high level and address any initial questions that anyone might have. And then I'd like to explore some key questions, which I will share here in the chat. One critical item that I'd love for us to discuss today is demand for this feature. So, what potential use cases and applications would benefit from this capability? And those sorts of answers will help us with the design and thinking more holistically when implementing. And I also just want to remind everyone that this is an open conversation. So I've started to outline the agenda and some, I'll suggest some questions, but really I'm just the moderator. You guys are all here to have an open conversation, and we have a full hour so we can take this conversation in a variety of different directions. So please feel free to chime in at any point. Every question is a good question. So I will post some initial questions in the chat. But in the meantime, maybe Michael, I'll hand it over to you to start.
Sounds great. Yeah, thanks, Michelle. So super excited to be talking about this, and yeah, feel free to interrupt at any time. I'll just do a quick rundown of what the ACP is, since it's been up, and I think most of you have taken a look already. But yeah, the general high-level idea here is that using Warp, you can prove arbitrary events across EVM chains without actually needing to interact on the source chain, or for the source chain to directly interact with the Warp precompile itself. The TLDR with how it all works is that EVM chains on Avalanche, yeah, let's share the ACP. Michelle, would you mind sharing the ACP, actually? Sharing your screen?
Yep, will do.
Thanks. Yeah, so it works by having the EVM chains be willing to sign all block hashes that they accept as warp messages. So typically warp messages are sent explicitly by transactions by calling the warp precompile. But for contracts that don't interact with warp at all, they can still just emit regular EVM events. And since the EVM Avalanche L1 EVM validators are willing to sign accepted block hashes, then you can get a warp signature over the block hash, post that onto the whatever chain you'd like to import this state into, along with a Merkle proof showing that a specific event was emitted by a specific contract on the other chain. So I think the main questions that we have here that I'd like to discuss is, one, is this something that contract developers want to leverage? I think there's a lot of interesting possible use cases, but I'm far from a smart contract expert myself, so want to make sure that people are actually excited to start using this. Two, assuming if that's the case, is the interface generic enough? And then if there are any other projects doing similar types of things that we should more closely align with for this standard. I do think it could be really powerful for L1 builders to be able to just use these contracts to find out events that have occurred on the C chain, whether that's price feed updates, whether that's NFT mints or whatnot. But yeah, I want to stop there, see if anyone has any questions or initial thoughts.
Just a quick clarification. I'm assuming that there will not be any gas cost on the target chain because it's an event, right? unless you code in such a way that you want to make a state change. Is that the case?
You'll still have standard gas costs on wherever you are importing state to.
You still have a gas cost. Okay.
So
if you're spamming, if you're sending prices, a lot of prices, for example, that's going to be a costly operation.
Yes. So for the price, like price feed importing case, you have to send a transaction on your L1 for each update that you want to import. But hopefully the L1 gas cost should be cheaper than on the primary network C chain. And two, you get to choose the frequency at which you want to send those transactions on the L1.
No, that's fine. On the L1, it's fine. But on the target chain, is there a gas cost? That's what I'm asking.
Gotcha. Sorry, could you define target? I was interpreting target.
Target meaning the chain that you want to listen to these cross-chain events.
Gotcha. No, there's no gas cost there.
Okay, perfect. That's what I assumed. So there's no gas cost in there. Okay.
Yep. Yeah, that's probably a helpful point. We should define, it doesn't really make sense to say source and destination because it's not a message. There's just a single chain that you're interacting on. So we should define some better terms for which chains mean what. But as far as where you're importing from, there's no gas cost.
Okay.
Yeah, that's why I was hopeful that this could be helpful for subnets for L1s because there's
maybe event generator, Mike, as instead of source and destination, we can settle on event generator chain.
I like that. What would you call the other one then? Where you're
event receiver.
Event receiver.
Consumer.
Yeah, event consumer, even better.
Thanks. I can definitely update the ACP with those. Yeah, any other thoughts on how this could be used for anyone building contracts on L1s?
I mean, I have a very specific use case for us for Dexalith, and it is not necessarily a must-have, but I can see that can be used. For me to explain this, I have to give you a little bit of how we work with the L1 and the C chain and other blockchains. So basically, when a user deposits from an C chain, let's just take it C chain, deposit from C chain, we lock the token on the C chain, and we send a generic message currently via layer 0. We want to implement AWM later, but we lock it, and then we send the credit message to our L1. So there is no real bridging of ERC20. And the depositor's address is credited, let's just say 100 USDC. And then with this credit, the depositor can buy AVAX. Let's just say he bought 4 AVAX. Now, at that point, I can see we generate an event on the subnet on L1. I can see that event being imported in the C chain. So there is an additional proof on the C chain that the current holdings of the user. And when the user wants to withdraw, it's the same flow, but in the reverse direction. And the locked amount of 4 AVAX would be given to the withdrawer. So currently, to mimic this, we are actually sending an IPFS Merkle proof just to have it as an additional feature. We do that, a version of this. But I guess it can be replaceable because that will be real time in that case, and there's no cost. So that was my first question for that reason. But this is very specific to our use case, so it's not necessarily a generic everybody can use this, and it will be like, something that is useful for everyone else. That's what I can think of as a idea.
Yeah, for sure. Do you think the interface proposed in the ACP is generic enough to meet that use case then? I think that would be the main question.
I apologize. I didn't really look that. I know I was supposed to. One of the reasons we were, I guess, we were the tasks that we had to. But for me, the import event called a bytes receive proof index block header. Okay, what's that? The next. So this call receive proof is call data log index. Receive proof. Can we put anything in this receive proof, or it's just has to be some
so the
predetermined?
Is a Merkle proof. It's a RLP encoded Merkle proof of the receipt that was emitted. Well, the receipt of the TX index within that block, of the transaction at TX index within that block.
Okay. I see. I have to get back to you on that if it's generic enough or not. To be honest, I don't want to say anything stupid at this point. Yeah.
Not at all. Sounds great. Thanks for the input. For that case specifically, it sounds like then the transaction is actually sent on the C chain because it's proving an event that took place on the L1. So you would still have that Avox gas cost, but yeah, definitely sounds possible. Just need to be careful around the timing of events. Like, just because an event took place at a certain point in time doesn't mean that's still like the latest event by any means.
Sure. Yeah, makes sense. Because there could be competing events and some race conditions, and we may not be sending the latest event, and that's a big assumption.
Yeah,
I got you. Yeah.
Is there like an existing actual example of that, like Merkle verification? Because I know like the block headers have been subject to some changes over time. So for instance, the C chain has that like extra data hash, and I think some of the newer ETH stuff has added in various like consensus client things to their block header. So like, are we expecting like a specific, like a super specific mechanism? Like, have we like thought about that? Like, have we like looked into implementing this yet?
So what we currently have, Stephen, it's not real time. So basically, I think every 10 minutes or even maybe longer period of time, we create a table of all users and their, all accounts and their balances. And we create a Merkle tree on that one, and we write the root of that to IPFS just to make it immutable. And we publish those periodically on our front end. So I think what Cengiz is suggesting, we can totally replace that with this one, something that can be generated on a transaction basis in relatively real time.
I guess
So
I was talking about
we don't have something set currently to replicate this basically.
Yeah, I guess, but for this ACP, like this ACP is basically using the block hash acceptances, authenticating that by a warp, and then doing inclusion proofs on the import stuff. So I'm not super familiar with how rigid the actual like inclusion proof logic is. I just haven't looked at, like, it might be possible that you can basically just have your header, you know that at like some point you're going to have your like log indices, and then you can just ignore like additional data perhaps, and that might be the kind of like best practice, because then you're just, you know, taking that this was an accepted header by the acceptance proof. So that might be sufficient. I'm just interested on like how robust of a like inclusion proof stuff we can make, or if we've like looked into that. I think that it should be possible, because I think for RLP they always add new stuff to the end, and so I would assume that we can basically just ignore like any remaining chunk of data and just look at what we care about. But I was just interested if like we've actually like looked into that for this inclusion stuff.
Not only, well, I wouldn't say I looked into it, but I stumbled upon it when it started failing, when trying to put together a proof of concept. Yes, Michelle, if you don't mind scrolling down to the proof of concept, actually, or clicking in, I think it's in a different repo. But you're exactly correct, Stephen. The block header for different chains can have different fields, but as long as the first few fields are the same, you can RLP decode those fields to get the value. The actual proof itself is just a generic Merkle proof against the receipts root hash that you extract from the block header. The encoding of the block header, need to make sure to query the RPC using the correct client interface. As far as if you look at some of the example code, there's a pivot between the subnet EVM or core ETH types because they have different block header encodings. It's like bang my head against a wall for a period of time. Like, why are these hashes not matching? I'm literally just querying for a block header and hashing it, hashing the result and going, and it wasn't matching what was on chain. But aside from that, the proof is all generic.
Thanks.
On the interface part, though, we might want to just make the block header. Actually, I forget, I need to double check. Is the interface defined the block header as just bytes, or does it define a block header? Yeah, it is just bytes. So different implementations could decode the block headers however they would like. One interesting extension of this, I think, is that Warp doesn't necessarily need to be used as the authentication mechanism. You could have the interface allows for any arbitrary authentication mechanism to be used. It could be, and that would be via a different contract that is responsible for providing that authentication. So for instance, you could have a contract that gets updated via multi-sig importing block hashes, and then the event importer just checks against that contract. And I think an interesting extension for that could be using this to make cross-chain applications from Ethereum, say, or other ecosystems. You'd still have to rely for now on a some solution in order to actually import the block hashes from those ecosystems, because you can't use Warp, but then you could use the same interface and same implementations of your cross-chain applications to prove events that have occurred on Ethereum or Avalanche. It's like if you used a layer 0 or CCIP or wormhole or et cetera to just import or publish what the latest block hash on Ethereum is, that theoretically any L1 could read that from the C chain using this interface and have a more or less direct connection to other ecosystems.
Quick
Yes.
question. So does that mean that every single event being generated would also generate a warp message?
I think it depends on how we define warp message, but functionally, I think that is that's basically what you get from it. I think of a warp message as data that is explicitly passed to the send warp message function of the warp precompile, but maybe that's too narrow of a definition. Like the warp message in this case is the block hash, and then using that block hash, you can prove any event. So you could definitely use this to build point-to-point communication, where you wouldn't need to call the warp precompile. You can just emit an event on the source chain. I'm not sure the gas costs or considerations of that, because the gas cost of the importing transaction depends on the number of transactions and the number of logs in the transaction that you're proving. So there's probably a lot of considerations to be made there. But yeah, you could definitely use or treat any EVM event emission more or less as a warp message in this
So my thinking is that maybe I'm wrong, but if there is any notable overhead to that, and I don't know if that's the case, maybe we should make that an optional, something like a private and public events.
So you mean overhead of calling the warp precompile to send a message?
Yes. And I don't know if that's true.
No, I think it'd be very interesting to investigate. Like if this could be used to make it more efficient point-to-point communication, because you don't need to call the send warp message event on the C chain. You know, if you're sending from C chain to an L1, and you just want to emit your event on the C chain rather than call the warp precompile directly, that could definitely. Yeah, that would definitely be very interesting to explore as a possible gas optimization, because it'd be more gas on the destination side, but you might not care about that because that's on the L1. Less gas on the C chain because you're just emitting an event rather than calling the precompile. That'd be super interesting for someone to explore the possibility of.
While we have the Dexalot team here, there's this question right here on timing and delays. I'm just curious if you guys have any thoughts on this particular question and just the threshold that would work for your particular use case.
For our particular use case, I guess delay is not that big of an issue, because it's going to be near real time, much better than what we are currently providing. So I don't necessarily have a threshold, to be honest.
I think it's interesting to, when I think of this sort of data replication or importing across L1s, an interesting world to think about is one where there's basically an Oracle chain. And instead of, like if we're in a world where we have thousands of L1s and many of them need price feeds for like directly offered on their chain in order for dApps on their chain to use them. It's not very feasible for, say, Chainlink to go and integrate all that, like however many thousands of those chains there are, but it would be very feasible for Chainlink to have a single Oracle chain, or any Oracle provider to have a single chain, and then any subnet could import the data from that chain onto their chain. But that does create this delay in the time from when the data is committed on the Oracle chain to when it's imported. So if that delay is like a non-starter, maybe that world isn't one that we would hope to see or will see come about. But I think it's interesting to think about those types of use cases for chains just to publish data.
I have a question regarding the gas usage again. So I guess when an event is generated, and on the L1, I will be listening, for example, and that's going to be gasless, and then I can have enough parameters to slice and dice to pick the one I want to import, and at that point I would be paying gas for that import only, not for the listening or slicing and dicing, right? Is that how it works?
Yep, exactly.
Okay, thank you.
The actual gas usage of the import does depend on the complexity of proving a specific event from the block header. So if there's, for instance, if there's more transactions in that block, then the Merkle proof of a individual receipt against the receipts route will have a higher gas cost because it's just the proof is a bit bigger because there's more nodes in this Merkle tree. But it is all just on the event consumer chain, as I defined it earlier.
Okay, thanks.
Will there be any interface for importing a batch amounts of events in the same block, or any similar concept, I guess, as opposed to just importing each event separately with a separate Merkle proof for each?
Yeah, that's a great question. I think it would probably come down to the specific use cases for it. If you expect to be importing multiple events from a single block, then you could write your contract so that you only verify the warp signature over that block hash a single time and then reuse that for multiple proofs of events. Or even, prove multiple events against a single proof, I guess, could also be possible. But if you're not, if you only have a single event that you want to import from a given block, then it might be more efficient to not store those verified hashes.
Yeah, that makes sense.
I think the interface should be generic enough to support either of those. I mean, it's definitely supports just a single event case, but I think it should hopefully be generic enough to also support reusing the authenticated block hash. Haven't done that though, so would be that could be a good thing to prove out before finalizing the interface.
Go ahead, Leah. Oh, thanks. Do you have a rough idea about the bounds for that delay we discussed, like minimum, maximum, like in terms of maybe block time?
The lower bound is definitely the next block produced on the event consumer chain. To make it explicit, what needs to occur is the block that the event is produced in the event generator chain is accepted. Then someone queries the validators of that chain for their BLS signatures of that block hash that was just accepted. And then they construct a proof, which can all be done locally. It's very low overhead, and put all of that data into the transaction that is then broadcast on the consumer chain. So theoretically, if the block obviously the block production is independent, but if there's, a second or more time between when the event generator chain accepts the block that contains the event you want to import, and when the next block is produced on the event consumer chain, it should be in the very next block. Or it's certainly feasible for it to be in the very next block. But there's also no upper bound. Like there's no guarantee it's ever going to be.
Yeah. Thank you.
I think, Michael, previously you did a proof of concept repo to show how to call chaining VRF from a subnet. So potentially that would be a good use case, right? To listen to the generated random event from the Chainlink manager contract on the C chain directly into a subnet, right?
Yeah, so that's definitely possible, but I don't think it is the best use case for event importing, just because it ends up being very point-to-point messages. You could. I'm not far from a VRF expert. I think a few other people on this call have much more knowledge of how VRFs can and should function than I do. But if there were something like a random number oracle that just publishes random numbers for others to use, then that could be replicated using this event importing. The VRF example proof of concept that we published earlier in the year was an explicit request for a random number. So like I have my application, I'm requesting from the random number provider that they provide me a number unique to my application itself. And since that's point to point, it's easier to build on top of Teleporter than this event importing format.
You could achieve something
You
like
could def-
that by just saying, please give me the next random number, and then as long like that happens after my request, and as long as a bunch of different chains all ask for it, then you batch it and you save on Chainlink.
Yeah, what you could do, right, is like, you commit to some operation with some like TX hash plus like request ID that's like monotonically increasing, and then you like take that random seed, hash all of that together, and that's effectively a truly random number. The only reason you want to add the additional stuff is just so that like everyone that requested a random number doesn't get the same random number at the same time. But yeah, you could definitely do like something like this to reduce the costs of I think I want to say DRAND is trying to do some stuff like that with their like publishing of randomness with like their BLS signing stuff. So yeah, it's definitely an interesting area for sure. That's how I would describe it.
That's very interesting. I hadn't thought of using it for VRF, but yeah, that makes a lot of sense.
How about in terms of a teleporter? I know previously we talked about once you send across your messages to the destination and getting the callback for whether the events you expect to get emitted when it's successful get sent back to the origin sender. Does that use case make sense for event importing?
Like as a receipt or acknowledgement?
Yeah, mostly just verifying what you expect happens for a teleporter message.
I think that's, well, this is interesting. There's probably a few different things that we could talk about here. I think as far as an explicit receipt proof, more or less, it's corollary to what Saki was talking about earlier, as far as it being more efficient to send an event or make a call to the word precompile, because that's just a message back. The fact that it's an acknowledgement of a previous message, I think, is just a like specific message type, but that could definitely be the case. I'm not sure. I think it'd be interesting to look at the gas cost of that. But similarly, the inverse case of proving a message never was delivered prior to a certain timestamp is definitely enabled by this, I think. Like if you have a message that has an expiry time, then maybe it's not with the well, something similar could work, I think. If you have a message with an expiry time that never gets delivered, then you could, once that expiry time's passed, prove that a block hash has been accepted with a timestamp past the expiry time of your original message, such that you know that message will never be delivered. It's not actually a proof of the event, but you could definitely use the sample code for importing a block hash and then verifying and extracting the timestamp out of the block header that matches that block hash for something like that. I was trying to piece that together on the fly though, so I'm not sure if it actually works or if people have other thoughts.
Yeah, I still have to think through your example, but also would have to think through how that compares with teleporter receipts, which I guess eventually you would be able to figure out whether your message was successful. I guess now that's just delivered, so you don't know if it's actually successful. Yeah, need to think through a bit more.
I think for that example, you'd also have to prove that the no blocks prior to the expiry timestamp block included the event of no.
Definitely. Thanks. I totally forgot about that part. It'd probably need to be against the state root. To like, or it's basically just an exclusion proof rather than an inclusion proof. But it'd be interesting to look if the interface works for that or not. Likely not, because it defines an event index, I think, or a log index. And it wouldn't be a log for an exclusion proof.
Going back to latency for a moment, the like end-to-end latency of generating an event on the event producing chain and then consuming it on the event consuming chain is the same as the end-to-end latency of a point-to-point warp message, with the only exception being, generating the proof off chain. But if we're assume that proof generation is won't impact latency at like the block scale, then it should still be the same latency.
Yeah, that makes sense to me.
I see we have a few other people from the community on this call as well. Just curious if any of you guys have any thoughts or questions. Feel free if there's like a concept you don't quite understand also to ask any questions there. Like this is really just an initial discussion introducing this ACP, so I think there probably are still a lot of early questions. I know we've been talking a little bit more about some of the details, but if there's any high-level questions, also feel free to ask.
Super like barely related question. But like for the Merkle proof, what is the actual structure of the Merkle proof for these things? Like obviously the state tree is like the radix tree stuff, but like for the stuff from the block header, like what's the actual format there? Like would we ever consider trying to, or I guess like how optimized is that already? And should there be consideration to try to optimize that anymore? Obviously, I think Ethereum has already use this a bunch, and any changes here would probably be a bad idea, but I'm just interested on like the landscape. I don't know, Michael, if you know.
Honestly, not off the top of my head. I'm just trying to pull it up in GitHub.
If no one knows off the top of their head, then I think I know where the code is, so I can play around. But
Yeah, I don't off the top of my head.
Steven, are you asking that because you're thinking of creating like a Merkle proof that could prove both inclusion and exclusion at the same time? We're just trying to figure out where the question coming from.
I don't really know that you can prove exclusion of an event. I suppose you could say like, this block only had 10 events, and you can prove that there isn't an 11th or something.
You can with a very big tree. It becomes expensive. So if your levels go down to include all of them, then you have like a null leaf where it wasn't existing, and then you can prove exclusion and inclusion. Just the tree becomes very deep, so the proof becomes very long.
No. I was thinking.
It depends on how the tree is keyed, right? Like if it's just, you could just have like a Merkle proof of like index 0 is the leftmost, 1, 2, 3, like, yeah. Anyways, I was just wondering like what the actual structure of the tree was.
So
I think it would make sense to change this for the record, because I think there'd be a pretty strong deviation away from ETH, and I assume people have already implemented this for ETH. So
the tree structure is the keys are the receipt indices, and then the nodes are the RLP encoded receipts, which would make it very difficult to do a event exclusion proof. You could do a receipt exclusion proof, obviously, but yeah. I think what a different similar line or type of primitive here would be using the state root of the block. I'm far from an EVM expert about how that state root's actually constructed. I know it's complex, and I know there's multiple trees within it, but I'm not actually sure of what a proof against that state root would look like for. I think you could do something like, I know if my message is accepted, then this key, or like this, state key will have a non-zero value. And then you could do a proof that the state key does have a 0 value after a certain point in time. But I'm not sure of all the details there.
Yeah, hello. I have a question of what it could look like on the relayer side, like, because I guess the relayer would have to know, well, we have to get notified that one block hash has to be, signed and forwarded to a specific chain. Like, I guess it would, if we want to support that, we would have to modify the Avalanche relayer implementation to support, like, relaying a message, or in this case, not a message, but relaying the proof based on a trigger, like triggering event, outside of noticing a message on the source chain.
Yeah, that's exactly right. It would need to be configured to listen for specific events from specific contracts that the person running the relayer wants to publish, and also pointed to where to actually publish them to. So there'd definitely be, like, I think we can abstract away much of that as far as the proof construction and the signature generation and whatnot, but it would definitely need to be configured for which events to listen for, one, and then two, how to, or what contract and how to broadcast them on the destination or the event
Yeah.
consumer chain.
Yeah, if I remember correctly, there was like at the time a notion of being able to notify a relayer that has to do something, or if maybe I'm wrong.
Yep. Yeah, I think that would still be like the
Like instead of having it configured, but like a way to, an API where you can say, okay, do that, like because I ask you to.
Oh, gotcha. Yeah. That could definitely be added to the relayer also, as far as like
Okay.
publish this event
Yeah.
through this contract.
Mm.
A separate thread or effort that we're working on is instead of building out more and more relayer functionality there, definitely want to enable users to be their own relayers. This doesn't really work for like or replicating data feeds, but in the case of like a user wants to prove that an NFT credential was minted to them on some chain, a relayer service isn't really best suited to relay that message because really it's just kind of a one-off thing on that the user wants to move into a certain L1. And to make that possible, really all you need is the aggregate signature. Other than that, wallets can construct their own transactions to broadcast any information onto the L1. So we're going to try to separate out the warp signature generation part of the relayer into its own API. So the API is not sending any transactions, but it can be queried by anyone just to get an aggregate signature. And assuming that API is publicly available, then UIs could very easily have users be their own relayers.
Yeah, it makes sense. Yeah, okay. Sounds good.
There's a discussion that I think has been thrown around from very early on in the warp conversations of like, oh, what if users just relay their own messages? But it turns out there's more and more use cases for that coming about. So it'll be great to get that in place.
Yeah, and I think Gautier, you bring up a good segue into this question of, does anyone have any other thoughts on, are there any existing standards or protocols that this should align with to improve the developer experience, or just thinking overall from like a DX perspective? Any other thoughts here? If not, that's also okay. I know. Yeah, go ahead, Matt.
I have a question about the arbitrariness of the interface, which might be slightly related, but pretty much like we're taking in bytes for the block header and receipt proof as opposed to actual constructed struct in order to support arbitrariness, right? And then I was just thinking, is it a worry at all in terms of the transaction index as well as the log index being typed as a UN256, and whether taking in a byte payload type or some form of a more arbitrary type would be considered?
Definitely seems worth consideration. I think it, just as far as proving having supporting proof types other than inclusion proofs of events, I think would definitely require some modification to the interface. I'm not sure if that would just be considered a different use case altogether or whatnot, but yeah, definitely interesting to think about.
Any other questions at this point? We can really just talk about anything at this point. Does it have to be any of the questions that I had sent here?
I have a clarification question. What is the difference between using the receipts route and a receipts proof as opposed to, can you use the transaction route in the block header?
Sorry, what do you mean by transactions route?
As in the EVM block header, there's the transaction route, state route, receipts route, and then in the event importer POC, it uses the receipts route and a receipts proof, right? Would it be possible to use the transaction route instead from the block header and then using a transaction proof? I don't actually know what is it optimization and gas, or like what's the difference between using different routes there?
I'm not sure what the transactions route is, or how it's constructed. I mean, let's see. Yeah, I'd have to check out how that transactions route generated to know if you can use it or not. The events specifically are only included in receipts, though, which is why one with that. There's definitely folks here that are far more familiar with the EVM block headers than I am, if you know how the transaction hash route is constructed.
I think it's the same like way.
I'm not
So-
sure that that's really like one-to-one with this, right? Because this is a much stronger building block, right? Using the events, because transaction can be built out of multiple other transactions, right? In smart contract, right? And so here you are kind of like going to the underlying event, which can be generated by different transactions. So I think that this one is far stronger as a building block.
Yeah, that makes sense.
And yes, for very trivial transactions, that's perfectly legit, right? No problem with that.
Yeah, that makes sense. I know we're coming up on now, but would be looking ahead to future things to explore regarding this ACP. It would be very interesting to see how the state route could be used, and if that's feasible as far as the complexity of on-chain operations to when the state size of a given contract's large enough, if you could still use that effectively, rather than just using events. Because there would definitely be additional use cases enabled by that we talked about as far as like exclusion proofs and whatnot.
You definitely can. Yeah, it's just you have to prove into the account tree and then
Like
then
it's
prove
definitely
into
theoretically possible. Definitely can, but I'm not sure how large those transactions are as far as gas costs.
Yeah, this is actually one of the main reasons I was interested, because like that has like a branching factor of 16, and I'd be interested on if the branching factor is different for these, but I would just have to look into the implementation. It's not too crazy.
Cool.
Great. I know we have 3 minutes left. Maybe I can just quickly summarize and then we can kind of wrap up from here. But yeah, I think the first thing is the Dexalot team talked about maybe potentially using this for their cloud product. So their users who are depositing tokens on C-Chain, importing information to the Dexalot L1. Sounds like the team will take a look to see if the interface outlined in the ACP is generic enough for their particular use case. I think that would be great. I think Leo on the Ash team mentioned potentially VRFs and random numbers. if you do decide to take a look into this as well, it'd be great to get any feedback on that ACP as well. And then Matt had mentioned receipts for either message delivered or message with expiry time was not delivered. So that's also another interesting consideration there. And then it sounds like on the question about timing and delays, there's no particular threshold for any application or use case in mind right now. It shouldn't be a big issue for now, but if that kind of changes, please do keep us posted. So yeah, anything else that anyone has thoughts on or anything I missed? Cool. Well, I will post a summary also in that discussion that I pinned here, and maybe just email everyone who attended this call a quick follow-up. Please feel free to continue the discussion thread, which I will send another link for. Michael had already opened one in the ACP repository discussion section. So please feel free to continue that conversation there. But yeah, really appreciate everyone's time here, and we're really on time, 1 hour pretty much to the dot. So thank you so much for attending.